So 9.2 deals with the conic section called an ellipse. And this will be very similar to a circle, I guess, except it's elongated either horizontally or vertically. So we'll have a focus point on the left and the right, or the top and bottom. So there's a focus on each side of the center, I guess. D1 to D2 would be a measurement, I guess, that we would take. And if we look further down, we'll talk about what D1 and D2 is, but it's 2A. It's 2 times the distance. There's what we call a major axis and a minor axis. And then we have what we call vertices. And some people call these co-vertices when they're on the minor axis. So when you look at it, these are the standard forms, again, that you'll want to know. Something like this and something like this. And what you'll notice is that A, they talk about A being the largest denominator, so the furthest spread from the center. So we're going to talk about that. And then when you find the foci, that's the plural of focus, either side of the center, you use this formula, which kind of looks like the Pythagorean theorem, except if you would add your a squared and b squared, it ends up outside of the ellipse. So a lot of stuff going on here. If a, or the larger denominator, is under x, the ellipse goes horizontally. If the a, or larger denominator, is under y, then the vertical will happen. All right, so we're just going to practice a couple of graphs. So I would take what's under the x. Now, technically speaking, that is the biggest denominator, so we're going to call that a squared. Now, a would have to be 5 to get 25, so basically just take the bottom number and square root it. So the square root of 16 is 4, and technically that's b. Now the center comes from the h and the k right there. So 1 to the right, up 2. So I'm just going to label things over here so we can see them. If you can write small enough to put it over there, do so. So my vertex is at 1, 2. Now, the x has the 5 under it when I took the square root. So I'm going to go to the right 5. 1, 2, 3, 4, 5. And that would be adding 5 to the x value. So that will be 6, 2. And then I'll go to the right 1, or left 1, 2, 3, 4, 5. That would be subtracting 5, so that's negative 4, 2. Then in the y direction, I'm going 4, so I go up 1, 2, 3, 4, adding to the 2 of the vertex, so that's 1, 6, and down 1, 2, 3, 4, 1, negative 2. So there's your ellipse, and you can draw it in, look something like that. Just slightly elongated horizontally. So the major axis goes right and left. So to find the focus, I'm going to do that formula. So you can't really mess up the formula, because if you add a squared, you'd end up with the a squared plus b squared, you end up with the square root of 41. And the square root of 41 is more than 6. So you'd end up with a focus here and a focus here. Well, they can't be outside of the ellipse. So when you subtract it, it'll work. And you have to do big minus small, or you'll end up with a negative number under the radical. If you take 16 minus 25, that's negative 9. You can't take the square root of negative 9. So it has to be c equals the square root of 25 minus 16. and that's the square root of 9, so C is 3. So I'm going to go to the right 3, 1, 2, 3, and put a focus, and the left 3, 1, 2, 3, and put a focus. Now this one would be negative 2, 2, and this one would be 4, 2. You just add to the x value of the vertex because you're going right or left. So here's your graph, or your standard form should look something like this. So negative 2, 4 is the center. Negative 2, 4 is the center. And then vertices are 2, 4, negative 6, 4, because you're going to the left and right 4. Then you'll go under the y is the 9, so you're going to go up and down 3, and some people call those co-vertices. And then when you do your c squared formula, you take the big one minus the small one, so that's 16 minus 9, which is 7, and the square root of 7, which is about 2.65. Not quite 3. So you go to the left, so I would take my negative 2 minus the square root of 7, and take the negative 2 plus the square root of 7, and just mark them, and those are the foci. I think on an earlier problem, yeah, I accidentally called this the vertex. We want to call this the center. Everything when you do the parabola is built off the center of for the ellipse. So vertices, co-vertices, all that go from the center. All right, then there's something called eccentricity, which is basically, is your ellipse more circular or is it more elongated? And so eccentricity is given by C over A. You can see here, if the eccentricity is given or found to be close to 0, this thing is really more circular. So you'll notice that the foci are not as spread out. As they become more spread out, the eccentricity gets closer to 1, and it's more elongated. So just a goofy thing here is the orbit of the moon. A lot of times you see things like drawn in books where it looks like this, and it looks like things are orbiting in an elongated pattern, but this is actually fairly small, so it should be, the orbits probably are more circular than anything. Just a note. So how does this thing work? So find the standard form of the ellipse, given it has a center, negative 2, 5, a focus at negative 2, 7, and major axis length of 12. So I would draw a picture, center at negative 2, 5. One focus at negative 2, 7. And the major axis has length of 12. So, it might be more elliptical up and down or something like this. So when I write out a standard form of an ellipse, I do x minus the x, so that's x minus negative 2, which would be x plus 2, quantity squared, plus y minus 5, the y value of the center. squared, and they're always equal to 1. So now, if the major axis has length 12, that means up 6 and down 6. So that's my A value. So when I square that, I get 36. Then the distance from the center to the focus is only a distance of 2. So that technically is my C value. So when you look at the C squared equals A squared minus B squared, I know C squared is 4. I know my big denominator, because it came from the major axis, is 36. And now I just have to solve for B squared. So if I subtract 36 on both sides, I get negative 32 equals negative B squared. Divide both by negative 1. B squared is 32. And so that should be my standard form. Oh man, I just realized I put them in the wrong spot, and maybe you caught that while I was lecturing. Because my major axis is 12, and notice I went up and down the 6, so that should have been under the Y. Up and down 6 means vertical, so the 36 should have gone there. And then when I found B squared, that would have gone under here. So that's a better, sorry about that, that's the final answer. Find the standard form of the ellipse with vertices at -4, -2, and 8, -2 with eccentricity of 5/6. So again, let's just draw a quick picture. -4, -2 is a vertex, and 8 -2 is another vertex. So if you find the halfway point between -4 and 8, that'll be the center, and that's at 2, -2. So I know I have x minus 2 quantity squared plus y minus -2, but we'll write y plus 2 is equal to 1. Now the distance from the center to the vertex is running horizontally, and this is the mistake I made on the last one. I put them in the wrong spot. Because it's going horizontally, and that's a distance of 6, 36 goes under the x. From center to vertex, vertices are running horizontally, so the big denominator goes under x. Then the y value, we have to do some work. Now, eccentricity, remember, is C over A. And so if that's 5/6, my C squared formula tells me A squared minus B squared technically. So C would be 5 squared, or 25. A would be 6, or 36. So what's B squared? And again, if you solve this, you get subtract the 36, you get -11 equals B squared, negative B squared. And divide both of those by -1. B squared is 11. So we can put an 11 under that one. So that would be your standard form. Okay, so example 6 is a DIY. Find the center, the vertices, the foci, and eccentricity of the ellipse. If you want to do a quick sketch off to the side, go ahead. Pause the video now. All right, so I know 2, -1 is my center, so I'm going to graph that, 2, -1. Now, under the x is the bigger denominator. I'm moving to the right and left 5 and only up and down 3. So go to the right 5, 7, -1. Go to the left 5, -3, -1. Up 3, down 3. So they've called they're calling the co-vertices 2, 2, 2, -4. They could have labeled them here. Notice though the center, vertices, foci, and eccentricity. They didn't say you had to find the co-vertices, but find them anyway. Now to do the the foci, you do c squared is a squared minus b squared, and when you do 25 minus 9, you get 16. Square root both sides, c is 4. So from the center, you're going to go to the right 4 and left 4, and you get 6, negative 1, and negative 2, negative 1 for those two focus points. And the eccentricity is c over a. So 4/5 for the eccentricity, about 0.8. So it is a little bit more elongated horizontally than it is circular. All right, as a DIY, rewrite this ellipse in standard form and identify all the information again. Pause the video now. So here's your standard form. If you would have done this, you would have moved the 1296 to the right. You always want the ellipse set equal to 1, so you have to divide by 1296, divide by 1296, divide by 1296. If you put this in your calculator, math enter, you get 1 over 81. Then you'll get 1 over 16. So now the center is at 0, 0, so right at the origin. You'll go to the right and left 9. So right 9, left 9, you get 9, 0, negative 9, 0. Excuse me. Up and down 4, so square root of 16. You go up 4 and down 4. And then your c squared formula helps you find the vertices, or the focus point. So 81 minus 16 is a square root of 65. You know, that's really close to 8. Actually, just slightly more than 8. Square root of 64 is 8. So you'll go 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. That'd be one focus, and there. Like this is 1. That's 1, and this is 1. And I would just say square root of 65, comma 0, negative 65, comma 0. And that's it.